try to answer this question by evaluating word alignments. So first, a short introduction to Romansh and NLP. Romansh is the fourth language of Switzerland. Why four? It's the last one to be recognized as an official language. That was in 1938. There are approximately 40,000 speakers. Most of them are in Graubünden. There are 5 dialects, and in 1982, a standard variant was introduced, Romansh. And there is some NLP stuff for Romansh. So in 2014, some folks at the University of Zurich created a morphological analyzer. There are some corpora. There's the Allegro corpus, and there's multilinguist, which is Johannes. So actually, it's a student at the University of Zurich, Manuel Weibel, created this corpus, and now it's on Johannes' website. And recently, TextShadow released machine translation application for including Romansh. So there is some stuff, but not a lot. But there is hope for Romansh. We could use a multilingual language model. And why would this be a good idea? It has been shown that mBERT performs well in so-called zero-shot cross-lingual model transfer, which is simply teaching the model a task on one language and then having it perform the same task on a different language. And multilingual language models were also shown to perform well with unseen languages, so languages that weren't part of the training. So we can be optimistic about Romansh and hope that mBERT or other multilingual language models will perform well. So this is a question: does mBERT understand Romansh? And what I did, I evaluated the word embeddings using similarity-based word alignment, and I used 2 aligners, SimAlign and SimAlign. And word alignments should, 1, be on par with statistical aligners, or statistical models, and 2, they should be on par with seeing languages, so languages that were part of the training data. And if both these cases are true, then we can confirm that the model contains meaningful information. So just a few words about similarity-based word alignment. Word alignment was traditionally, or is traditionally done with statistical models. So you probably heard about the IBM models 1 to 5. But recently, similarity-based word alignment was suggested by using multilingual word embedding. And let's see how it works. So this is a very simplistic example with some fictive numbers. And if we have 2 parallel sentences in 2 languages, so let's say we have an English sentence, I love apples, and a German sentence, Äpfel liebe ich. We extract the embeddings for these words from the model. We compute the similarity between the embeddings for the words in these sentences, and we put them in a matrix with values between 0 and 1. So this is what the matrix would look like. And then we align the word in the first sentence with the word in the second sentence if they are the most similar. So in this example, I and ich are the most similar, love and liebe, and apples and apple are the most similar, and they will then get out. So, like I said before, there are 2 models, at least that I know, that use this method, SimAlign and SimAlign. And the big advantage is that there's no need for parallel data, and it is not influenced by dataset size. But it is slow if you don't have it. And in fact, you can go on SimAlign's website and just enter 2 sentences in 2 languages, and without any training data, the model will compute the alignment. So to test whether MLMs contain meaningful information, to evaluate the word alignments, we need a parallel corpus and a gold standard. And I collected a corpus, which I call the German corpus. It's a multilingual corpus with German, Romansh, and Italian. And I collected press releases published in German, Romansh, and Italian, published by the Cantonal Cover in the years 1997 to 2020. So if you know the 11 corpus, it's basically the same, but their work was until 2010. So I just took whatever they did and I continued the job. And I scraped the website for the years after 2010. I aligned the documents using URL matching. I put everything in JSON files and in a SQL database. And I aligned the sentences using. And this is what we get. The corpus has around 4,500 parallel documents. And for each language combination, around 100,000 unique sentence pairs. So we also need a gold standard. And I annotated 600 sentences using a software called SimAlign, which was created by some folks from Iceland. And let's assume I have these 2 sentences. And when I told about this work, when I told people about this work, I was often asked if I speak Romansh. I don't. But, and I don't want to step on any toes here, but I'm a trained linguist. Romansh being a Romance language, which has many cognates with Italian, French, and Latin. The task of aligning words with German is not very difficult. So if we have this example here, the word Medienpaket should obviously be aligned to Paket and Medias. And the word Bundes, Confederation. So I'm pretty sure almost everyone here in the crowd would be able to do these alignments. I also consulted the dictionary and the grammar, so that wasn't. Okay, so now let's get to the numbers. So as a short recap, I said that embedding-based word alignments should be on par with statistical models, and they should be on par with C language pairs. And if this is true, then I assume that the information is meaningful. Is it on par with statistical models? Let's look at this plot. So the y-axis is AER, which stands for alignment error rate. This is just a metric combining recall and precision, and the lower the better. And the x-axis are the sentence pairs, and I compared the baseline models. I took, I'm not sure how to make this work. So baseline models are FastAlign and FLOMO, the statistical models, and the similarity-based models are SimAlign and SwissText. So what we can see is first that the statistical models get better the larger the dataset size is. And the green line, the similarity-based models, is constant because it doesn't rely on dataset size. And we see that the similarity-based models are just in between the baseline models. So SimAlign and SwissText perform better than FastAlign, but worse than a flow model. So is it on par with statistical models? Yes, it is. Now the second question, is it on par with C language pairs? These are numbers reported by the folks from Munich who created SimAlign. So for English, French, I hope it's large enough. They report an AR of 0.06. For English, German, 0.19. And German Romansh is 0.22. So this is also within the range of reported AER on C languages. So also this question, yes, it is on par with C language. So to conclude, embedding-based word alignments, and I used mBERT, so I didn't mention it before, but for these two things I used the embeddings from mBERT, are on par with statistical models, as we have seen in this plot, and they are on par with C language pairs. And from this I conclude that mBERT contains meaningful information about language. Now, why does it work? So mBERT didn't see Romansh in the training data. Like I said in the beginning, it was shown already that multilingual language models perform well in zero-shot scenarios and on C languages. And it's actually unclear when this is the case. When do they perform well on C languages? So some researchers say that subword overlap is important. For Romansh, this would be obviously the case with other Romance languages like Italian, French, Spanish, etc. And some other researchers say that typology, similar typology, is important. And this will also be the case for Romansh. There's a Sprachbund called Standard Average European. So you all notice that European languages are all very similar. And Romansh is also one of these languages. And this would also favor the case of Romansh. Right, and there's a quick bonus. SimAlign actually says, in the paper they say, why only use embeddings? We can also train or fine-tune the embeddings on parallel data. And this is what I did. I continued fine-tuning mBERT on the sentence pairs that I extracted from the corpus. And these are the results. After fine-tuning mBERT on the parallel corpus, recall went up by 20% almost, which means it finds more alignments. Precision went up by almost 14%, which means less errors. And in total, the AER went down by almost 60. So we heard before, numbers are boring. Yeah, okay, this is better, but what is better? So let's have a look at a quick example of the alignments. Blue is the gold standard. The circles are SimAlign or mBERT before fine-tuning, and the black boxes are after fine-tuning. So what can we see here? Okay, so you see the word Dolev. In the beginning, it wasn't correctly aligned, and after fine-tuning, it got correctly. Why? This I don't know, but maybe the Romansh word roof is just too dissimilar to French loop or to Italian lupo. But it had to learn it, and now it can align it. Another example, a slightly longer sentence, I hope you can read it. Here, the model learned the Romansh negation. So this word naginas is a negation here in the sentence, and you can see in the beginning the German word keine was aligned to a different word, which was wrong, and now the model learned the correct alignment. And also this preposition here, auf, is correctly aligned to Eyal, and that was before fine-tuning not the case. So it seems that now the embeddings represent the idiosyncrasies of Romansh better than before. And what can we learn from this? So one thing, maybe it would be a good idea to, in order to include low-resource languages in multilingual models, is to fine-tune the models on parallel data instead of monolingual data. And a second thing that we might do is use the fine-tuned mBERT embeddings for other tasks, like DOS 13 or which is something I didn't try, but for this you would also need those standards. But this is thank you, that's it.
Thank you very much for this very good presentation. Question, topic?
Okay, I do have 3 questions. That was quite interesting. Why do you say it's on par if you see that FLMR performs better than the training data? So, line of error rate. And number 2, have you considered using fMRR, which train on the whole set of data with better results, not requires for this language pair? Maybe.
So why do I say it's on par? It's within the range of the 2 baseline models, and I think SimAlign established itself in the literature as a legitimate baseline model. So yes, I mean you can say it's not on par because there is still a statistical model that is better, but there is also a statistical model that is considered as a legitimate baseline and it's better than that one. So maybe yes, I completely agree, and maybe the question should be how did SwissText get accepted as such a baseline model, which is used in many other papers as well. It's not so cool. Maybe. But I still think that after fine-tuning it beats also FLOMA. And no, I haven't used FMOA. I think it's like a rehash of FLOMA, or FLOMA is a rehash of the other one. I only tested these. Okay. And the third question? Okay.
Thank you very much for an interesting presentation. I have 2 questions. So the first question would be what constructed your matrix, and then you fill the matrix by similarity between the two. So how you assign, you make a kind of dynamic programming in order to expand. So if yes, what is the size of the window you are?
So this is just a very simplistic explanation of how the similarity-based alignments work. This is reiterating what, in a very simplistic way, what is in the line in the SimAlign. Yes, this uses dynamic programming, and they use cosine similarity to measure the similarity between the embedding.
Are you able to detect the first word which is similar to the last word? and it's kind of a large window.
But if I can detect the first word and the last
word. Align the first word of the sentence with the last word of the sentence of language.
Yes, these algorithms also have methods to deal with many-to-many alignments, for instance. But this is more the mathematics of the algorithms, which I just don't understand enough to answer this question.
Okay, the second question, did you try the sentence alignment?
What about sentence alignment?
Sentence alignment, we try to align sentences, not words.
Oh yeah, I mean it's part of the corpus is sentence alignment, for which I used Hunala, and this is how I get these sentence pairs. Is this a question?
Yeah. My question. So you have tried this on the Romansh language? Or?
Yes, it's German. For German Romansh, I have around 100,000.
I try to take different numbers.
In the sentences, yes, it's because everything. I think it's not really transparent on the website of the canton, but I think almost all the press releases are written in German and then translated either to both Romansh and Italian or only Romansh or Italian, according to what they think may be relevant.
Any other question? That's one question about you. Based on this study, you conclude that mBERT is kind of have you tried to other than tasks like this? Since I was, you mentioned both like what kind of limits, but I think one obvious choice would be classification. I guess from these articles you have some kind of something try to classify really do something more tangible that it actually understands language. I mean, I'm not saying
so. Of course, I use the word maybe to understand because of course, a language model doesn't understand anything, right? But the representations are meaningful. This is what I try to show. I haven't tested on any other tasks except word alignment.
So my next question would be about compounds or structures and function words. Function words don't have any, they have a representation in space, but probably has anything to do the other side. But in that example, if you look at Volksschule, Lehrerinnen, Lehrer, and then you have the Insegnante della Scuola Popolare, how well does it handle one-to-many or many-to-many alignments? How did you do this for the gold standard? Because if you measure an error rate and you do something with gold standard that the algorithm can't handle, you will always end up with bad numbers.
Right. In the paper, I also explain a bit more about the gold standard. German compounds I aligned in one-to-many, like did it here, like here. And this is something that I also noticed that after fine-tuning worked better. After fine-tuning on SimAlign, compounds were aligned better than before. Prepositions I aligned in the gold standard, and articles as long as they were translated. Like here, so in this case, this remained unaligned because it has no representation. And so I'm talking about the definite article il, in German, there's no definite article here, so I just left it out. The preposition I aligned is one. And also in the example, we saw that this preposition, no, I left it unaligned. Just the lexical representations and not the these function words.
Okay, in the interest of time, I think we have to move to the next session. Thanks a lot.
Thank you.